This lesson is on Chapter 3, Section 3, Polynomial and Synthetic Division. If you guys would all open up your textbooks to page 266 and get your notebooks ready, we'll get this one going. Okay. When dividing polynomials, if you know one zero or one factor, you can divide that one out and find another one. Okay, so it's just like if you guys know in our breaking down a large whole number, so for example, if you're working with 90 and you know that 9 goes in there, you can divide the 9 out and get a 10, and then you could break it down and find another factor. Polynomials work the same way. So if you can find a factor and pull it out, you can shorten the polynomial or look at what's left of that polynomial. Maybe you can easily factor it like we've been doing with quadratics or whatnot. So our larger polynomials, we try to find one zero, or we try to find one factor, get it out of there, and then continue to work with it. Now you guys have worked with long division in polynomials before. So let's do a quick review of the process. If we have 3x squared plus 19x plus 28 divided by x plus 4, the division process is just going to have us figure out, well, how many times would x go into 3x squared? And it would go in there 3x times. Okay, so you're looking at that first part of the divisor outside, and then the first term inside your division box. 3x times x is going to give me 3x squared. 3x times the 4 part has to be done as well. 3x times 4 is going to be a positive 12x. Subtract. Okay, 19 minus 12 is 7x. 3x squared, of course, minus 3x squared is gone. Once you subtract in long division, you drop the next term. Now, how does x go into 7x? It will go a positive 7 times. 7 times 4 gives me 28. And subtracting is gone. So this one comes out even. It does not have a remainder. If one factor is x plus 4 and we divide it out, we find that our last factor is 3x plus 7. Okay, if you wanted to check yourself, okay, you guys know that an answer to a division problem or a quotient multiplied back to the divisor should end up giving you that polynomial that you started with. Okay, so always consider that as a check for yourself before you make or before you abandon it and figure your answer is right. So that's kind of summed up here by what's called the division algorithm. It essentially says that if you divide by a divisor and find a quotient or find an answer, multiplying the answer back to the divisor should return you to the dividend. Okay, so I kind of diagrammed that out here for you. And again, it provides you an opportunity to check your answer. One key thing with long division, or in this lesson we're also going to be looking at synthetic division, sometimes some of your powers are missing. Okay, so your polynomial maybe has a fourth power in it and a third power in it, and maybe it skips the x term or x squared term. You're going to want to fill in with a 0x squared in that spot. You want all of the descending order powers in a polynomial expression. Okay, so if one of them is missing, put in a 0 term to take that spot. So for example, in our x cubed minus 2x squared minus 9, notice that we do not have an x term. So right in here, we're going to insert 0x so that the first power has something to represent it. So setting up our division, x to the third minus 2x squared plus a 0x minus 9 divided by x minus 3. Okay, so x into x cubed would be x squared times. X squared times x is x cubed. A negative 3 times an x squared is a negative 3x squared. And subtract. Negative 2 minus a minus 3x is x squared. X cubed minus x cubed is gone. Drop. X goes into x squared x times. So I get an x squared. X times negative 3 is negative 3x. And subtract. 0 minus a minus 3 is going to be 3x. Drop your next number. X goes into 3x, a positive 3 times, and I get 3x minus 9, and it comes out even again. Okay, so my quotient is x squared plus x plus 3. Let's take a look at this one. Okay, so something that you're going to have to be watching for is if the polynomial has not been written in descending order, you're going to want to make sure that you catch that and rearrange the terms so that it is. Okay, so in looking at this one, this is actually not a third power or a third degree polynomial. There's a term in there that has a fourth power. We want that to be first. Okay, so you want to have the highest power and work your way on down to the smallest. So 6x to the fourth. Then there is a third power one in there, write that one next. There's a squared term, write that one next. There's a plain x term, and then there's a constant. Also, you're going to want to have your divisor in descending order as well. So put your positive 3x out front and your positive 1 last. And then the process is like we've been doing. So 3x into 6x to the fourth will be 2x to the third. That's going to give me a 6x to the fourth. 2x cubed plus 1 is positive 2x cubed. And we subtract. A negative 1 minus 2 is negative 3x cubed. And drop. 3x into negative x cubed is going to be a minus x squared. So I get my negative 3x cubed. And then negative x squared times 1 is negative x squared. Now notice when I subtract here, they're gone. Okay, but I still have numbers to drop. So I'm going to drop that 9x. Now because I'm going to be putting up a number and multiplying by 3x plus 1, I know I'm going to end up with a constant as well. So I'm going to also drop the negative 3 so that I have a constant over in my dividend side as well. So 3x into 9x goes a positive 3 times. And I'm going to get 9x plus 3. And when I subtract, a negative 3 minus 3 is negative 6. So this is the first one that we've worked with that's had a divisor. Okay, so we have a remainder of negative 6. Now the way I want you guys to write divisors is write them as a quotient. Okay, if we were going to, think about whole numbers when we do long division and they don't come out even. You know how you would tack on zeros and you'd keep on dividing. Okay, I want to still divide negative 6 by my divisor. But I'm obviously not going to end up with decimals here in polynomial land. So I want to just have that quotient or that division stated as my remainder. Okay? So you have your polynomial part, and then I would end up with a negative 6 over 3x plus 1. All right, another option for division is kind of a shortcut. Okay, a lot of people like this process a little bit better because it's faster. It's called synthetic division. Okay, now I've attempted on the next slide, some of you guys really like steps to a process, so I have attempted to list steps. Okay, hopefully these steps in my wording make sense to you. If not, we can go over it together in class and I can help explain it more. I think as I get into the next slide and we actually do an example together, if you're sitting there with the steps open to you as we go through them, I think it'll make more sense. So you might want to pause right now, jot the steps down into your notebook, and then we'll take a look at an example of this together. All right, so if we were going to divide this problem, in synthetic division, your divisor is in the form of x minus k. Oops, my pen doesn't want to write, hang on. Okay, so in order for this to be a plus 2, what k value must it be? Okay, so hopefully you guys recognize that it would be k of negative 2.
Ethan Mars, if you are in the building, please meet your mama at the front doors. Ethan Mars, please go to the front doors to meet your mom.
Sorry about that.
Larson, if you are in the building,
All right,
please
so
go to the high
let's try to
school
talk
office.
through that.
Summer Larson to the office.
So in synthetic division, we don't have to keep the entire dividend and divisor. We're going to look at the coefficients and this value k of the factor. Okay, so k goes here, and you kind of do this inverted box, and the coefficients all line up here. Again, if there's a missing term, okay, if one of my powers of x is missing, you need to fill in a 0 in its spot. Okay, this particular one has a third power, second power, first power, none. So it has them all. But if there's a missing one, you got to include that 0. All right, so my process. Drop the first one straight down. Okay, so I'm going to drop my 5 straight into my bottom. Now I take k, or negative 2 times 5, and I put that product up under my second number. And I combine. 8 and negative 10 together make negative 2. Repeat the process. Take negative 2 times the divisor. So negative 2 times negative 2 is 4. Combine. A 4 and a negative 1 is 3. A negative 2 times 3 is negative 6. Combine. I get a 0. Okay, so this tells me that x plus 2 is a factor of the polynomial that I started with. It came out even. Okay, now here's the other thing that we're going to get out of this, or this is how we interpret our answer. These numbers, the 5, the negative 2, and the 3, represent the coefficients and constants of what are left if I take x plus 2 out of that polynomial. Okay, so the 3 would be my constant term. The negative 2 would be the coefficient of my x, and the 5 would be the coefficient of my squared term. Okay, I think most of you guys know that if I were to divide x plus 2 out of that third degree polynomial, I would be left with some kind of an answer or a quotient that began with a squared term. Okay, so that's how you take those numbers left over from your synthetic division and turn them back into that polynomial answer from your division. Okay? Now, in most cases, we're going to be able to take that polynomial or that quadratic and continue to factor it. All right, so when it has a third degree, those are harder to factor. If we know one and we can divide it out, we might end up with this 3-term trinomial that can be factored pretty fast. All right, so this is kind of summed up with the remainder and factor theorems. If you divide a polynomial by a factor and get a remainder, the connection between that remainder is if you were to stick k into the function, you would actually get that number as a value of the function. Okay, so it's kind of a, I don't know, kind of a nice little connection there, that if you have your factor and you divide it out, you get a remainder. That remainder is the value of the function at f of whatever that number is. Okay, that'll make more sense when we do one. Okay, this number 47 is one that I pulled from the homework, and it talks about the remainder in a problem, but I found it really confusing. Okay, so there was directions in this section that said write the function in the form f of x is equal to x minus k times q of x plus r. All right, so in English, please. Okay, x minus k, this part, that's one of your factors, or that's the divisor of my problem. Q of x, this is how they don't designate the quotient. So that's like the answer. Okay, so that first chunk's the factor. Q of x just says, okay, that's the answer to your division. That's the quotient. Then plus r means just plus the remainder. Now think about that. If you were to do a division problem that came out with a remainder, okay, I gave you guys 40 divided by 4, or 50 divided by 4. You get 12 remainder 2. All right, if I were to take 4, my divisor, and multiply it by my quotient, okay, my answer to the division was 12, and add it to my remainder, I would get back to my 50. Okay, that's what this is saying in function notation. So I just found it kind of clunky in that function notation, so I thought I'd try to dissect that and explain it a little better. All right, so in other words, 50 would be equal to 4 times 12 plus 2. There's the x minus k. There's the q of x, or the quotient, and here's my remainder. Okay, so maybe that clarifies that a little bit for you, I hope. Now let's give it a try. Write the function in the form f of x is a factor times its quotient plus the remainder, and then we're going to prove that f of k is equal to that remainder. All right, so k in this case is going to be a 4. So what I want to do with this one is I'm going to use my synthetic division, and I'm going to divide that first factor out. Okay, so if I go with my 4, I'm going to list my coefficients in here. I have a 1, -1, -14, and 11. And do my process, drop the first one. 1 times 4 is 4, combine. 3 times 4 is 12, combine. -2 times 4 is -8, combine. I'm finding a remainder this time. Okay, remember how that other one that we did ended up with a 0? It came out even. This one came out with a 3 at the end. There's a remainder of 3. So according to our remainder theorem, if I were to plug k into my function, so if I were to now evaluate f of 4, I should come up with a value of 3. So let's check it. Okay, so putting f of 4 through, I would have 4 to the third minus 4 squared minus 14 times 4 plus 11. So 64 minus 16 minus 56 plus 11. And sure enough, if you put 64 minus 16 minus 56 plus 11 together, you do in fact end up with 3. Okay, so again, it's a way that you can check yourself. If you're doing function evaluations, if you're doing synthetic divisions, the two of these can check each other. Okay, so that's what the remainder theorem is telling us. Use the remainder theorem to find each function value given the f of x function on the screen. All right, so if we're doing f of -1, in other words, they're telling us that our first k value, or our first factor, is going to be a -1. So let's quickly do our synthetic division on it. We have a 4, 10, -3, -8. So working our process, drop the first one. Then 4 times -1 is -4, combine. 6 times -1 is -6, combine. -9 times -1 is +9, combine. And we get a remainder of 1. Okay, if the remainder theorem holds true, f of -1 should also give me a 1. So let's test it. Put in the -1 for all of the x's. So 4 times -1 cubed is -4. 10 times a -1 squared is a +10. -3 times -1 is +3. Putting that all together, I end up with 1. Okay, so that one checked out lovely. I purposely pulled one that had a f of a half. I used a fraction one, just to show you can still run a fraction through synthetic division as well. Okay, so let's do this one. None of them in this one get too bad. Same process, drop the 4. Now 1/2 times 4 is 2, combine. 1/2 times 12 is 6, combine. 1/2 times 3 is 3/2. Now -8 combined with a +3/2 is a -6.5, or a -13/2, whichever you want to write it as. Okay, so there's our remainder. Let's check it through with evaluating our function at 1/2. So 4 times 1/2 cubed, I'll jump ahead here, plus 10 times a half squared minus 3 times a half minus 8. Okay, so 1/2 to the third power. 1/2 times 1/2 times 1/2 is 1/8. 1/2 squared is 1/2 times 1/2, or 1/4. 3 times 1/2 is 3/2, and then the minus 8 on the end yet. So 4 times 1/8 is 1/2. 10 times 1/4 is 10/4, or 5/2. 1/2 plus 5/2 is 6/2. Subtract 2/2 is 3/2. And I've got a 3/2 minus 8, kind of just like I did back in the synthetic division box. I'm going to get negative 6.5 again. So it checks out for fractions as well. Okay, so now this is going to show you how the division process can actually take something like this bigger polynomial of a degree 3 and help us find all of the other factors. Okay, so if you can divide one factor out, what's left, your quotient, is going to be a smaller polynomial that you might be able to factor quite easily. Okay, so for this first one, I like synthetic division better. I'm going to use that. You could use long division on this as well if you wanted to. So if this is my factor, my k value is a negative 3. Okay, so I'm putting down a negative 3. Now notice in this polynomial I am missing an x squared term. Okay, so my first coefficient of my cubed term is a 1. I'm missing x squared. Fill it in with a 0. My x term is a negative 19, and then I have a constant of negative 30. All right, do our process. Drop the 1. Negative 3 times 1 is negative 3. Combine. Negative 3 times negative 3 is 9. Combine, you get a negative 10. Negative 3 times negative 10 is 30. This one comes out even, no remainder. Okay? And it should, because they flat out told you that x plus 3 is a factor. You should expect a 0 there at the end. If it doesn't, then you made a mistake. Okay? Because if it is in fact a factor, it should divide evenly into the problem. Now, what polynomial is left? Okay, so with 3 terms, the last one of which is a constant, that first one again is going to be a squared, my x, and my constant. Okay, so it's one of those regular quadratics. This one too, it's a simple enough one. I don't think you'd need quadratic formula or anything on this to finish factoring this way. So x plus 3 was one factor. They handed us that. We just found the other two. Okay, one way that you could check yourself to make sure you're right, you could multiply those 3 all back together again, and it should take you right back to x cubed minus 19x minus 30. Okay, assignment on page 272 this time. There are a few that I want you to turn into me. 12, 28, 48, and 56, just to give you a real small taste of a few of the things that I've just gone through. Okay, so if you've got questions, come on in and see me.